Hi folks, let's take a look at question 3 from the test 3 preparation sheet. So look at the question. Gives us the flight time from Toronto to Vancouver with a headwind is 6 hours, but on the flight back with a tailwind 4 times stronger than the original, the flight took only 5 hours and 15 minutes, and they give us the distance between the cities, and they're asking us to determine the speed of the plane and the speed of the original headwind. Okay, so the trick to solving these problems is that if a plane is flying with a tailwind, then it means the speed of the plane is increased by that amount of the tailwind, whereas if you're flying into a headwind, your actual speed will be lower than the speed of the plane by the amount of that headwind. Okay, so let's start by defining our variables, and as is often the case, the key to defining the right variables is in the question itself. They're telling us what it is we need to determine. So we'll say let v be the speed of the plane. Okay, and we'll say w will be the speed of the original headwind. Okay, so now let's start by writing an equation. So let's start with the first scenario with a headwind. So if we take the speed of the plane, okay, the actual speed will be lower and lower by exactly the amount of the headwind. So we're going to subtract the speed of the headwind, and that'll give us the actual speed the plane is moving at. But we know that the distance is 3,360 kilometers and that it took 6 hours, so we can determine that speed by dividing distance and time. So that's 3,360 divided by 6. Okay, and let's calculate that here. 3,360 divided by 6, and we have 560 kilometers. So V minus W is equal to 560, kilometers per hour. And that'll be our first equation. So now let's write an equation for the trip back. Okay, and here again we have the speed of the plane, but since there's a tailwind, it's going to be increased by the amount of that tailwind. What's a little different in this question is it's not the same speed of wind. The tailwind here is 4 times that of the original headwind. So instead of adding W, I'm going to be adding 4 times W. 4 times the speed of the original headwind. And here, let's calculate what that final speed is going to be. Well, I have the same distance that's going to be traveled. However, here it's going to take, not surprisingly, less time since the speed is being increased. And here it's going to be 5 hours and 15 minutes. So 15 minutes is a quarter of an hour. So that'll be 5.25. So V plus 4W is equal to, and let's just calculate that, 3,360 divided by 5.25 is equal to 640 kilometers per hour. Okay, and this will be our second equation. So while we can use substitution quite easily, I'm going to stick to my usual procedure of using elimination. So I've got V minus W. Don't need to actually multiply anything since we have V in both equations. Okay, so we're going to subtract these to eliminate the V variable, and we're left with negative W minus 4, so negative 5W is equal to 560 minus 640, that's negative 80. Okay, and so here W is equal to, well, 8 divided by 5 is 1. Okay, left with 3, so that's 16 kilometers per hour. So we have here the answer for our original headwind, which is 16 kilometers per hour. And now let us go back and determine the speed of the plane. Okay, and the easier one to use will be equation 1. So again, I'm going to label the equation that I'm using. So we have V minus W, which is 16, is equal to 560. And so the velocity of the plane, 560 plus 16, is 576 kilometers per hour. And there we have it, the speeds of the two planes. Okay, that's it for now.